On June 1, 2009, Air France Flight 447 departed from Rio de Janeiro to Paris on what was supposed to be a routine overnight flight across the Atlantic. On board were 228 people. The aircraft was an Airbus A330, a modern long-haul jet equipped with advanced fly-by-wire technology and multiple automated safety systems. Everything during departure appeared normal. The weather forecasts indicated storms along the intertropical convergence zone, but nothing unusual for transatlantic flights. As the aircraft cruised at 35,000 feet over the Atlantic Ocean in the middle of the night, the pilots navigated through areas of turbulence and towering storm clouds. Then, at 2:10 Coordinated Universal Time, a series of automated maintenance messages were transmitted via satellite. These messages indicated inconsistencies in airspeed readings. The pitot tubes, small sensors that measure airspeed, had likely become obstructed by ice crystals at high altitude. When reliable speed data was lost, the autopilot disconnected. The aircraft suddenly transitioned from stable cruise to manual control in severe weather and darkness. Within seconds, warning alarms sounded in the cockpit. Conflicting speed indications created confusion. The pilots pulled the nose up, possibly believing the aircraft was overspeeding or descending too rapidly. Instead, the aircraft began to climb steeply, losing aerodynamic lift. At high altitude, thin air leaves little margin for error. The plane entered an aerodynamic stall, a condition where wings no longer generate enough lift. Despite stall warnings sounding repeatedly, control inputs continued to keep the nose elevated. For more than 3 minutes, the aircraft descended rapidly toward the ocean while still in a stalled condition. There was no clear distress call. At 2:14 Coordinated Universal Time, the aircraft impacted the Atlantic Ocean. It disappeared into deep waters nearly 4,000 meters below the surface. The crash initiated a complex multinational search effort. Debris was located days later, but the main wreckage and flight recorders were not recovered until 2011 after an extensive deep-sea operation. When investigators analyzed the black boxes, they reconstructed the final moments: a chain of technical malfunction, loss of reliable data, human stress, and aerodynamic misunderstanding. The investigation concluded that temporary icing of the pitot tubes led to unreliable airspeed readings, which triggered autopilot disengagement. In the confusion that followed, inappropriate control inputs kept the aircraft in a sustained stall from which it never recovered. The tragedy changed aviation procedures worldwide. Pilot training programs were updated to emphasize manual high-altitude flight handling and stall recognition. Airbus modified certain systems and recommendations regarding airspeed sensor reliability. Aviation authorities strengthened requirements for pitot tube performance in extreme conditions. Flight 447 became a defining lesson in modern aviation, not because of a single catastrophic explosion or structural failure, but because of how small technical issues combined with human reaction under pressure can overwhelm even advanced technology. Today, the story of Air France 447 remains a powerful reminder that even in an age of automation and sophisticated aircraft design, pilots must always be prepared to take control in the most challenging conditions.